Grade 9, you learned about linear relationships, and the equation has an exponent of 1. So for example, y equals 5x plus 7. The exponent is always 1 in a linear relationship. Quadratic, what's the highest exponent in a quadratic relationship? You learned that this year and last year? 2. Okay, it always has an x squared term, so this is just an example. The third type of relationship you're going to be learning is called exponential, and it looks something like this. So it's written in the form y equals a to the power of x, okay? So we'll talk about what that means later on in the chapter, but if we were just to look at the graphs, graph 1, would that be linear, quadratic, or exponential? You just learned about quadratic relations. Graph 3, we know this is what? Linear, okay? And an exponential relationship, the graph is either increasing or decreasing, okay? So the graph here is an example of what? Increasing or decreasing? What do you think? Is this graph, pardon? Increasing, okay? The graph is either increasing and it's a curve. It could be increasing or decreasing. And it's approximately, one end is almost flat as it approaches the x-axis, okay? So you're going to learn more about this, but the curve actually goes parallel. It's almost flat with the x-axis. It does not actually ever touch the x-axis, and I'll explain why. Okay, so as we know, if we look at a graph, linear, we know it's a straight line, and the slope or rate of change is constant. If you had a table, what do you remember from linear equations? How can you see from a table that it's going to be linear? Good. First differences are the same, so if you want to add that for linear. What about quadratic relations? How can you tell from a table if it's going to be quadratic? Second differences, good. Second differences are the same, and we know that the graphs are parabolas, okay, and they can have a maximum or minimum point. Like I said, we're going to be investigating exponential relations. So what are some characteristics of the graph? Well, I just told you a couple. Graphs are either increasing or decreasing. The graph is a curve that's approximately horizontal at one end and increases or decreases rapidly at the other end. Okay, so if you want to underline that. One end of the curve may become almost flat as it approaches the x-axis. So again, if this is my x-axis, it's a curve, and as it approaches the x-axis, it becomes almost flat, but it will never touch the x-axis. Okay? It's written in this form, which you're learning in this course. It will always pass through a point, 0, 1. All of these graphs will have an intercept at 1. To figure out if a relationship is exponential from the table, you're going to find the ratio, okay? We're going to find the ratio of the y values. So to find a ratio, 4 divided by 2. What's 4 divided by 2? Next one, 8 divided by 4. 2. 16 divided by 8. 32 divided by 16. And finally, 64 divided by 32 is 2. What do you notice about all the ratios of the y values? They're constant. Okay? In an exponential relation, if the ratios of the y values are the same, it's going to be exponential. If I want to rewrite my y values as a power, well, the first one can be 2 to the power of 1. That's also 2. What's the next one? 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5. 2 to the power of 6. This is increasing exponentially. The exponent is increasing by 1 every time. I want you to tell me if this is going to be exponential. So you're looking to find the ratios of the consecutive y values. So ratio of the first one, 6 divided by 2, and 18 divided by 6, and so on. So once we calculate all the ratios of the consecutive y values, the ratios are all the same, which means that if we were to graph this, this will be exponential, okay?
Made with Doodlecast Pro.